Alright, so today is Unit 3 inverse functions. We're on day 2 square root functions, which is itself an inverse function. Starting off, we're going to graph the function f of x equals x squared. That's just a review of units 1 and 2, so throwing me those coordinates in, you should know how to do this already. And there we go. Alright, now let's actually take that function and let's actually do the inverse of the function. If I were to do it algebraically on number 2, I would actually swap x and f of x, so it would now look like x equals f inverse of x being squared. To solve for f inverse of x, I'd take the plus or minus root of x. So f inverse of x equals the positive or negative root of x. Now what that's actually is, that's actually not one function, that's actually two functions put together. One of the functions is the square root of x, the other function the negative square root of x. So this is not a function. Alright, to just get that out of the way. Today's class we're actually going to be usually just looking at the positive root, though it is possible to see negative root, and we'll get into that later. Number 3 said to actually graph that function, and I'm actually going to do it by inverting each of these points on this graph, and then I'll show you what it's doing. So if I were to take the point negative 2, 4 and invert it, negative 2, 4 would become 4, negative 2. Again, that's reflecting in the line y equals x, swapping x and y. Take the point negative 1, 1, that becomes 1, negative 1. Now for 0, 0, if I swap x and y, it stays 0, 0. And for both of these 2 points, 0, 0 and 1, 1, they actually lie on the line y equals x, so they aren't going to change. And then for 2, 4, it'll become 4, 2. And this is actually my graph right here, is it's a parabola opening to the right though. Alright, what's going on here? Like if you were to take these points and plug them in as x values, if you took x equals 0 and plugged it in right here, plus or minus the square root of 0, you would get 0. Now let's go out to x is 1. If you were to take 1 and plug it in, plus or minus the square root of 1 is 1 or negative 1. So 1, 1 and 1, negative 1. Take the square root of 2 rationally, same for square root of 3. If you were to go out to 4, if you were to take the square root of 4, you'd get 2 or negative 2 because all these were plus or minus. Now you'll notice that this graph does not exist anywhere over to the left. And that is because this would be taking the square root of negative values, and that would be imaginary. We're only on the real axis here, folks, so let's just keep it there. What you will notice, for the original function, the domain would be all real numbers. The range would be anything greater than 0. F of x is greater than or equal to 0. But now for this new function, this plus or minus root of x, which is actually two functions, we have a new domain and range. The domain would now be only values greater than or equal to 0. And the range would now be actually all real numbers. It will continue to go up for forever. It will continue to go down for forever. So you will see that anytime you invert a function, you're also not just swapping x and y, you're also swapping your domain and range. Your input-output flips. That wraps up our warm-up. That's just leading into where we're going with this today. You can see in this bit of notes I've got posted up right there, the parent function is simply the square root of x. Again, you will not see positive or negative on today's notes. It is possible for you to see it in the future, but when you do, that's not a function. It fails the vertical line test. Here we're only looking at the positive root of x. So it starts at 0, 0, goes up and to the right from there, as you saw on the previous screen. The domain for this parent function is always greater than or equal to 0. The range, here it's not all real numbers because it's only the positive root. It's greater than or equal to 0. The intercepts, you can see, I don't really talk about those too much. It is not defined for any x value less than 0. And here's its end behaviors. You haven't seen that too much yet, but as x approaches 0, y approaches 0, that's where it ends. And where does it end on the right? Well, it doesn't have an end to the right, so it ends at positive infinity, but y approaches positive infinity as well because it's going up. Go ahead and identify the domain and range of this function. Domain is always the easiest thing in the world for square root functions, and here's why. Whatever is underneath the square root, in this case, x minus 2, take that and set it greater than or equal to 0. Reason being, whatever you take the square root of needs to be 0 or positive, and that's what I've represented here. I'll add the 2 on both sides. X is greater than or equal to 2. We just figured out our domain. All right, as far as the range goes, go ahead and write that in. This is f of x. Now, it's not all real numbers because it's only the positive square root. Since it is the positive square root, I know that it's going to be anything above what value. To know that value, just take this 2 that we found a moment ago and plug it back in. 2 minus 2 is 0, square root of 0 is 0, so it's greater than or equal to 0. By the way, it's always going to be whatever number, whatever value is outside the square root. It's kind of like vertex form, believe it or not, and we're going to see that in a minute. Alright, so doing yet another problem, domain and range-wise, which is really the important thing is these square root functions. We can graph them, and if you are in class with me, you'll see me graphing them on the calculator and showing you what's going on. As far as domain goes, taking the x plus 4, setting it greater than or equal to 0, so x is greater than or equal to negative 4. Alright, that's my domain. It is that step every single time. Take what's under the root, set it greater than or equal to 0, solve for x. That's all you got to do. The only time this is ever going to be less than is if there's a negative coefficient on the x, and that is not going to be seen in this course. As far as the range goes, again, this is not going to be all real numbers because it is not plus or minus the root. So we are only going to have f of x, and it will be greater than or equal to because it's the positive root here. What number is out here? 0. Excuse me. If you take the negative 4 and plug it in right here, it would evaluate to 0. So there you have it. There's your domain and range. All the 3 is doing on this problem is that it's going to be stretching it vertically. So if you were to graph it, and I'll make a quick sketch of it, it's starting at negative 4, 0. And when we go over 1 unit, instead of going up 1 unit, it would actually go up 3 units now. And when we go over 4 units, let's see here. Right here would be going over 4 units. Instead of going up 2 units from the original, we're going to multiply that by 3 and we're going to go up 6 units. So it really stretches it vertically by having that 3 on there. That's what it's doing. I told you a little bit ago this was related to vertex form, and here's your formal notes on that. You can see a, x minus h, and plus k. Just now we have a square root on the x minus h. H is your horizontal translation, exactly like it was with your quadratics. K is your vertical translation, again exactly like it was. If a is less than or 0, meaning if the a value is negative, you're reflecting in the x-axis. Instead of going up, you're actually going to be going down with your function. If the a is greater than 1, it's vertically expanded, they call it. Vertically stretched is what I've been saying. Those words work well together. If the a is between 0 and 1, it is vertically compressed. Okay, so this is exactly the same rules that we've been following for vertex form, just now it's on square roots. So I'm going to apply those rules here and actually get this thing graphed out pretty easy. Going to go ahead and figure out where this thing is starting. It is starting at the coordinate positive 4, positive 1, minus h, plus k. So I'm going to go ahead and graph out the point 4, 1. That's where this thing is starting. Okay, it is your vertex of the parabola, just your parabola is opening on its side. I know that I'm going to be going up from there, all right, because it's a positive root. Now, how do I do that? Let's go to where the vertex is, and let's go over 1 unit. And the square root of 1 is 1. So I should go up 1. But remember, we've got to multiply that by 3. So I'm actually going to instead go up 3 units. There's a good second point. Now let's go over 2 units from my vertex. If I go over 2 units from my vertex, can I take the square root of 2? Not nicely. Alright, I cannot take the square root of 3, but I can take the square root of 4. The square root of 4 is 2. So I'm going to go up 2. But we got to multiply that by 3. So instead of going up 2, we're going to go up 6 units from where the vertex was to 8, 7. Alright, and I could continue this on out. I just don't have any more room on my graph because if I go out 5 units to where the 9 is, I can't take the square root of 9 or 5. I can't take the square root of 6. Can't take the square root of 7. I'm just out of room on my graph. So it starts here at the vertex. Sorry about that. It starts here at the vertex and it goes like this. And it will start to even out as you go, but it will never stop going up. Alright, that's important to realize. Now we can state domain and range. You could do the same process as we did before, but you can actually see it visually now that if I take x minus 4 and say it greater than or equal to 0, x has to be greater than or equal to 4. And we can see that right here, that 4 is the first place where x exists, and it exists for values higher than that. Though some of these values are giving you irrational numbers, they are part of your domain. Okay? For your range, f of x, y is what we're using here, it's going to be greater than because this function was going up. Greater than or equal to, what y value? 1. It started at a y value of 1. That was the first place it existed, and it went up from there for forever. Okay, we're going to graph the function negative root x plus 5 plus 2, and we're going to state the domain and range. You know what, for this and for your homework really, if you're just graphing it on your calculator, that's the cool thing. I don't really need anything outside of the domain and range. Is what I'm really checking for here is that you're getting that right. So you can actually do domain and range without graphing it, but let's go and throw it in there, see what it looks like. So negative square root of x plus 5. Be sure you hit to the right to get out of the root before you type in that plus 2. That's a good note to take really quick. Alright, I'm going to use Zoom Standard, and if I follow my form, minus h plus k, I know that it starts at negative 5 plus 2 is where this is starting at, negative 5 plus 2. And sure enough, I see that here. It's at the point negative 5 plus 2 that it starts. Now this one is going down, and that's because of an a value equal to negative 1. When it was negative, it's going to get stretched downward. I could see points for this thing if I go to second table, and I'm going to scroll up to where it starts, negative 5, 2. You can see your calculator is giving you errors beyond that because this would be root of a negative value, and your calculator doesn't like such things, and we don't need to worry about them here. Alright, so stating domain and range. My domain is that x needs to be greater than or equal to negative 5. Again, I could have gotten that by doing x plus 5 is greater than or equal to 0. Subtract the 5 on both sides. My range, in this case we used a y. This one, though, is less than or equal to due to the negative on the front of the root. And it will be less than or equal to the 2. 2 is the highest value that this function has for your y values. Alright, there's my domain and range. Alright, I told you, hey, you're not going to see a negative x value inside the root, but hey, you're honored, so why not throw it at you? What we're going to do is just go ahead and state the domain and range. Let's take the negative x plus 2, set it greater than or equal to 0. Now let's see what happens there. See, it is the same exact step and process as before. Just here we'll subtract 2 from both sides and divide by negative 1. Please remember, when you divide or multiply by negative, that will flip your inequality sign. So it's now less than or equal to positive 2. Kind of weird. This graph's actually going to go to the left. This is my domain. For my range, follow the same rules. F of x is in this case going to be greater than or equal to because it is a positive root. And it's going to be greater than or equal to negative 3. All right, there's my domain and range. I'm going to graph that out really quick on my calculator and confirm that. So, going to my calculator, y equals, throwing it in there. The root of negative x plus 2, hit the arrow to the right to get out of the root, minus 3. And when I hit graph, I can actually see that I was correct, that it's any x value less than 2. Any x value less than 2 and to the left works. Any y value negative 3 or higher works. So there's my answer. That confirms it right there. And this is a scale factor of 1, so it didn't get stretched or compressed vertically from our parent graph. All right, pretty long problem, but actually really easy. What's going to happen here is when an object is spinning in a circular path of radius 2 meters with velocity v, in meters per second, centripetal acceleration a, in meters per second squared, is directed toward the center of the circle. That's that feeling that you have in a car that when you're going through a turn, your body kind of goes towards the outside of the turn, away from the center of the arc. Anyways, that force is associated with the acceleration that you're feeling, and so this is a good example of where these root functions are used, that the velocity in this situation would equal the square root of 2 times the acceleration. So what would be the centripetal acceleration, we're looking for A, of an object spinning along the circular path with a velocity of 4 meters per second. We're actually given v here. So we can actually make use of these equations now like such. Like I could put 4 in for v equals the square root of 2a, and I can figure out what my acceleration is throughout this experience. So first thing I would do is follow my order of operations, and following my rules for solving, I will square both sides to undo the square root. So 16 equals 2a. And then I'll divide both sides by 2, and I'll get my acceleration is 8 meters per second squared. And there we go. Easy as that. Really, just trying to give you an example of where this is used in context to the real world. Just one example, there are tons of them. And that wraps it up, folks. I really appreciate you tuning in.